So, hello everybody. Okay, seems to work. Okay, maybe as a short introduction, we're currently contracted with ESA to organize the operation. So the results and the analysis that you will see is an outcome, but it's also quite a collaborative work between many people, and we're also looking forward to employ the automation to the system for future activities. Okay. Okay, now it works. I will start with the performance of the station and something about the conditions, go over to the data amount and the distribution, tell you a bit more about the precision and accuracy, and introduce you some of the experiments we did with the calibration and also activities on the station. So this is a brief glimpse into the performance. Keep in mind that the current baseline is the 1064 nanometers with 550 microjoule pulses at a 400 Hertz repetition rate. This is a piggyback setup, and the reason for that is that there are other astronomical and optical observatories that would be disturbed by the green laser beam, which is why we're focusing on the infrared. And of course, we also have less noise in the infrared, which is helping with the observations. We got a good performance overall, instantaneous. Here is an example for DiGOS. If you take a look at the plots from the ILRS website, this is the observation per normal points over the range, and over here on the right you can see that we achieve a return rates up to 4% per normal point, almost down to the horizon. This is pretty nice, and over here instantaneous from a figure from the scope software we're tracking at a 26 degree elevation. We had a return rate of almost 15% for DiGOS, while we turned down the laser energy to 30%. Keep in mind this is with the low energy laser at 400 Hertz, but of course this is possible with the 80 centimeter telescope that we are using. And this performance also is mostly possible, or in large parts possible, due to the local environmental conditions. If you look at humidity over here plotted on the right, on average we don't get above 60% during wintertime, again on average, and even below 20% during summertime, so it's quite a special site. And also the temperature change is pretty low, like around or even less than 10 degrees during a day, and also on average throughout a year only 12 degrees Celsius. And it's easy to understand what that means if you look out the door and remember the days that we had like 2 days ago. You could have like 2 to 3 degrees during nighttime here in Yebes, and during the day up to 18 degrees. And so this is quite a smaller change, which is of course very nice. Also, one nice thing is that we have a no-flight zone, so we almost never see an aircraft, which is nice. On the other hand, we get quite high dust concentrations from time to time due to a Kalima blowing desert sand over to the Canary Islands from the Western Sahara. And down here on the left, you can see the measured dust concentration by an instrument in the on-site. And we have a variety of security levels defined or color-coded over here, and you can see that during this 2-month period we actually were hitting the maximum possible dust concentration for observations quite a few times. So this is one downside that we experience with this site. Okay, a bit about the data amount and the distribution. I took a look at the ILRS website system performance table 1 during this time frame, and overall we submitted 879 passes during that time frame. Let's take a look into the shares as a figure. It's quicker and easier to read. 54% GNSS, 26% DiGOS, and only 20% DiGOS, while an average ILRS station would submit 63% LEOs, 16 DiGOS, and 21% GNSS. So you see it's quite the other way around, and that's interesting. But of course, as said earlier, the focus of the station or the focus of ESA is Galileo, but also the contribution to the ILRS with respect for the reference frame, for example. And consequently, we have our statistics down here. If you look to the right in green, also again a mean ILRS station, basically the average values. We see that we have less normal points per passes than other stations, but we have more minutes of data per pass and also more minutes of data per normal point, which is just due to the fact that we do a lot of GNSS passes. In perspective, these shares will likely stay similar, but the output is already increasing as we have new observers working on the telescope, and we will also employ automation in the future, so that the ranking hopefully will improve from the currently only the 30th spot. And of course, overall, if we get more data, this is good for ESA, but this is also good for the ILRS. Let's take a look into the system position. Here we have the chain for the green, a 7 picosecond pulse width. The detector has an RMS of 22 picoseconds, in the infrared 8.5 and almost 30 picoseconds. And again, taking a look into the ILRS website, table 1 visualized over here on the right side. Again, for an averaged mean ILRS station, Tenerife in blue, and the best value that was reported in yellow, we can see that for the calibration RMS and the starlet RMS, the Izana station is somewhat average, but if you take a look at the DiGOS RMS, we're getting pretty close to the best values that are reported, which is kind of a nice feature, or also a strong point of the system. And also with respect to data accuracy, we will take a look over here into the development of the system delay throughout the last year on the right figure. And of course, for 1 year, sorry, you can see the seasonal trend in here. So that is at first okay. We can see a daily change around 20 picoseconds, which is also okay. And also this daily spread is basically stable throughout the time frame, except for some outliers. And there was one thing I was looking at during the last days, which would be kind of a change of the trend here towards the end, but that change is basically also matching with the temperature development over the same time frame, because we're getting to a different plateau than compared to 1 year before. And of course, we will have to take a look on those outliers and take a look into the books in order to understand what has happened here, and you will also see some of those effects probably on the next slides. That was beginning of August, so we keep that in mind. And then I received a recent update from ERICOS on the station position, here shown for the north component, the east component, and the up component. And you can see we almost have no drift. The values, the offsets also shown down here in the table, are almost all at millimeter level, except for the STD of the up component. So that looks pretty good. Of course, we also have one value popping out over here, large STDs at the beginning of August, and this might be related with the change in system delay that we saw before. But if we take a look at the range biases from the 2 analysis centers, Hitotsubashi, did I say it right this time? Hitotsubashi, okay, all right, I'm sorry. And JSET, so okay, again, thanks to ERICOS for this quick update. Over here, I only show the range biases for LIGEUS 1 because there's the most data. And at first, we take a look to the trends, and you see that the average trends, they are in agreement. The mean value is a little bit lower for Toshi's results than for the JSET results. And interestingly, here the outlier is not present. So I guess I will get into a discussion with Toshi and maybe also with ERICOS what this means to understand this. And then I also did one more thing, taking a closer look to Toshi's pass-by-pass analysis provided by this website. It's always a very good tool for pass monitoring. If somebody is doing something wrong, we can see it pretty quick in there. So thanks for that. And what I basically did was creating or calculating an average value for every pass occurrence and also deriving an STD value from that. And interestingly, even though it's just a somewhat preliminary analysis, pass by pass, you see that the average value is in agreement with Toshi's result one slide before, or it is close, because this is -9, while the other result before was around -6 millimeters. And interestingly, also over here, the outlier at the beginning of August is not as present as we saw in the station position, which again might be correlated with the system delay offsets that we saw. Okay, something about calibration experiments that we also did with the fiber. We did full calibration runs over 10,000 echoes while we applied a variation of the laser energy, which results in a change of return rate. For the green chain here, of course, plotted in the green, and also the infrared plotted in red, and I applied a significant level of 2 millimeters, 6 picoseconds, because that's when I saw that the trends were significantly changing. I normalized the calibrated system delay to 0 to make a direct comparison possible. And you can see that the infrared starts to significantly drop off around 20% return rate, while the green with the compensated spot is capable of going up to 30%. However, operationally, we keep the return rate below 15%, here indicated with the black line, in order to make sure that we don't overexpose our detectors and good quality ranges. In perspective, we could also think about increasing this level for the compensated spot, which of course would be good for LEO observations, for example. Then something about further station experiments. We have already seen those results yesterday from the talk from Francisco. This was a dedicated simultaneous tracking between the Izana station and the Potsdam station at first. Here for a 2 hours long pass to Galileo 207. A few other passes were done, and during this very long pass also the Graz station and the Beijing station joined at some point in time, not planned, they just did the ranging anyways. And it's interesting to look at the single differentiating measurements that Francisco already showed, because I see a potential application for an analysis of station systematics, because if we look into those single differences up here on the right, just for this individual pass over the 2 hours, we see a pretty nice agreement around 2 millimeters between Izana and Graz, but around 30 millimeters for Izana and Potsdam, so this gives me something to think about. And this is not only for this single pass, but you can also extend this to longer time frames, and then it actually becomes interesting, because down here you see such differences between end of February and beginning of July. And again, over there, the difference between Izana 1 and Wetzel were around 2 millimeters, and with Potsdam up here around 34. So there might be some potential in doing such a station monitoring. I think I have to think a little bit more what we really see with those single differences, but it could be scheduled like once a month, for example, within the ILRS, in order to get a better picture. Now I'm told I have to hurry up, all right. We also did some dedicated tracking upon request here to the OPSAT, 10 millimeter corner cubes you see here in this plot, and an array from Graz. We received some data. I'm going to jump a bit quick because this is more interesting. In preparation of the ELRS station upgrade, we also did observations to cooperative targets. You see the list over here on the right. We got quite plenty of them in a 2 weeks time frame. One target is popping out, which is this one, and after internal talks, we think that this does not have a retroreflector. If anybody knows, please let us know. And I was thinking, well, even though it's infrared, this is not the highest pulse energy, but you could think that this might be the highly reflective section enabling this. There's some further discussion, and you know, due to the rotation, you get quite some interesting results, but still SLR provides good ranges. Then we did some experiments on spin period estimation. You have the Topex, you know this. You get the 9.5 seconds period from SLR residuals. But we also recorded light curves here for JSON2 in order to take a look at spin periods. And there you also see the period standing out clearly. We had some amplitude changes throughout the pass, and that's interesting to explore further. And so I will jump to the summary. Overall, you saw that the Izana 1 station is contributing actively to the ILRS while we're ramping up the output currently. We have a large GNSS and LaGeos share due to the focus on Galileo, but also the ILRS contribution with respect to for the reference frame, for example. We saw a good station data precision and accuracy. Stability is pretty good. We did some return rate calibration experiments. We have the automatic energy control in order to employ good data quality. The station is also a testbed. We did simultaneous Galileo observations where there might be a potential for station monitoring, for example, within a EUROLAS campaign. We did observations upon request. The observations to cooperative targets where we even might have one uncooperative target. As I said, we have to discuss, and spin period estimation from SLR residuals and light curves. And of course, the Izana 1 contribution to the ILRS is beneficial for both parties. We provide data that we also need, but we also get a monitoring that is valuable for us. And with that, I would like to say thanks for the attention and also to the ILRS.
Thank you, Sven. Any questions from the audience? Got one in the back over there. Okay. Oh, sorry.
Hi, Sven. Thank you for that. I'm quite surprised with the results that you showed about the return rate calibration with the CSPAD and the infrared. I thought the CSPAD would hold its ground much better than that. Just it did withstand a higher return rate than the infrared, which I suppose is just a SPAD with nothing to it. But a 30% return rate, you already saw a drop. Is that what you expected from this device?
I actually took a look at the SPAD first time with more detail during those runs. I heard that there could be a potential for even higher return rates, but that's basically the experiment that we did and what we saw. And you're right, you could expect more from the compensated version, but still, as you all, basically I'm repeating a point, 30% is quite a lot if we think about single photon.
Yeah, if you think about single photon, but if you think about multi-photon, for instance, the Graz people in Austria, they are essentially don't have any higher limit on the return rate than for LEOs, and they get well, maybe for AGSI 90% or whatever, and they don't seem to be too worried about that. Whereas you showed that with supposedly a similar or identical device, from 30% or so is not this. Well, maybe we can ask Ivan later.
Yeah, I just wanted to say that. Let's get in touch with him.
Okay, thank you. There's some questions on the online here.
All right.
So the first one is, have you carried out a quantified overall benchmark comparing Izana, is it Izana or Izana? Izana, okay, Izana with other sites?
In that case, I would have to ask in which way qualified benchmark. I think, so my first reply would be, we get a pretty good benchmark by looking at the performance tables from the ILRS website. I think it would be a question of what you want to look in more detail. So this is the best you could get from what is available online, and I see quite a lot of information in that actually.
So we also have a comment. It appears on TIDA there is a long-standing station that is part of Aeronet, an international network that measures aerosols. Data might be useful to compare with Izana 1 station sensors. And one last question online. How close to some sort of automation are you with Izana 1?
So basically we understand the systematics and have a variety of components already available. We have a variety of systems already active that can do automated tracking. For example, you have a deviation of the pointing in the sky, and we have algorithms that continuously hold the target. And also for the other components, when you need to know where to start the search, we have modules ready for that. So basically, we're currently in the step of combining all the things and doing a monitoring if everything works well with that.
Excellent. Let's see. Oh, you got another one online. You're blowing up. Is there a GNSS station at the same site and tied to Izana 1?
That's something that Andrea would have to answer, I guess. I guess there is, or it will be deployed, right? It will be deployed, okay.
Next year, okay.
Next year.
Great, thank you.
Thanks.
And I think, thank you, Sven.